Hi everyone. Today we're going to learn how to solve applications involving linear inequalities. There are phrases that indicate inequality. For greater than, you will see these words: is greater than, is more than, is larger than, exceeds. For the inequality greater than or equal, you will see these words: is greater than or equal to, is at least, is no less than, is the minimum. For less than, the phrases are is less than, is smaller than, has fewer than, is lower than. For the inequality less than or equal, the phrases will be is less than or equal to, is at most, is no more than, is the maximum. These are now the steps on how to solve applications involving linear inequalities. Step 1. Read the problem and identify what is required. Step 2. Represent the required by a variable and translate the condition into an inequality. Step 3. Solve the inequality. Step 4. Check the answer in the problem and make sure it makes sense. Let's start with example 1. Translate and solve, then graph the solution on the number line and write the solution in interval notation. The phrase is 27 less than x is at least 48. The x we will write first. The word less than denotes minus, and the 27 words is now written as a number. It's here. The word at least is greater than or equal to, and that number 48. So we will solve for x using properties of inequality. We want to make this x alone on the left side of the inequality. We want to remove this negative 27. So what we will do, we're going to add 27 to the inequality. It means to the left side and to the right. So the negative 27 and the plus 27 will become 0. Only the x comes down here. So greater than or equal to, the sum of 48 and 27 is 75. So our answer is x is greater than or equal to 75. For our graph, we're going to write the number line, put the 75 on the graph, and check again our inequality. The inequality suggests all numbers greater than or equal to 75. So our solution set from 75 itself and all numbers greater than the 75. So it will be like this. All the numbers on the number line that are on the right of 75. And that includes that 75. For the interval notation, we will put the solution set. Our lowest number is the 75. All the numbers greater than 75 is now represented by the infinity. For the 75, we use this square bracket to denote that 75 is part of the solution because of that symbol greater or equal to. and the parentheses for the infinity, because as a rule we put parentheses if there is infinity involved. So this is our final answer. Let us have example 2. Aliyah has $25 to spend on juice boxes on her son's preschool picnic. Each pack of juice boxes cost $2. What is the maximum number of packs she can buy? In step 1, we're going to read the problem and identify what is required. So in here, we want to know the maximum number of packs. In step 2, we will represent the required by a variable and translate the condition into an inequality. We let n be the number of packs. Now, given that $2 times the number of packs is less than or equal to $25, this is the money of Aliyah. So we will write 2 times the n is less than or equal to 25. We will solve now the inequality, and that is our step 3. In solving, we would want to make n having coefficient of 1. So what we will do, we will divide this inequality by the coefficient of n, and that is 2. So now it becomes 2n over 2 is less than or equal to 25 over 2. And we can cancel the coefficient and the divisor. So the n is less than or equal to 12.5. We will check the answer in the problem and make sure it makes sense. But the n must be a whole number of packs. So we will round this number into 12. It means to say Aliyah can buy a maximum of 12 packs, because this 12 times 2 will give $24. And this is our final answer. Let's have example 3. Michelangelo is planning a 6-day summer vacation trip. He has $800 in savings, and he earns $10 by selling one painting. The trip will cost him $510 for airfare, $700 for food and sightseeing, and $200 for the hotel. How many paintings must he sell to have enough money to pay for the trip? We will go for our step 1. Make sure that we understand the problem and identify what is required. So we want to know the number of paintings. Step 2, we will represent the required by a variable and translate the condition into an inequality. We let n be equal to the number of paintings. Now in here, the total expenses is less than or equal to the sum of the savings plus the income from selling paintings. So putting all the expenses here, the 510 plus the 700 plus the 200 is less than or equal to the savings 800 plus the income 10 times n. We will solve now the inequality. First, let us simplify the left side. The sum of these three numbers will be 1,410. And we will just copy the inequality, also our right side members. Next, we want the 10n to be alone on this side. We want to remove the 800. So we will subtract 800 on the right side. The same value we will subtract on the left side. So this 800 minus 800 becomes 0. The 10n comes down on the next step. We will find the difference of the two numbers. It becomes 610. Then we want to make the coefficient of n equal to 1. We will divide this inequality by the coefficient of n, which is 10. So here it is now 10n over 10, and the left side also is 610 divided by 10. We cancel now the coefficient and the divisor. We have now the n. The left side now is simplified into 61. So our inequality is 61 is less than or equal to n. We want to make this n be on the left side and the 61 on the right side. If we put the n first, look at the sign now. The less than or equal to becomes greater than or equal to. And then the 61 is now on the right side. We will check the answer if it is correct. If Michelangelo will sell 61 paintings, 61 times 10 is 610, plus the savings 800, he will have this 1,410 to cover the trip expenses. So Michelangelo must sell at least 61 paintings. This is our final answer. I hope you learned something from this video. See you again next time.